Hello everyone, my name is Nasrin and my today's presentation is about cochlear localization in CT images using image registration. To have a better diagnostic and surgical plan, a three-dimensional view of cochlea is needed. To obtain this view, we require to segment the inner ear in CT images. If you would like to design an automated algorithm for this purpose, one of the initial steps could be localization. I have implemented an image registration algorithm to locate the cochlea in the head CT images. To detect which image from the training data we need to register to the current test image, this equation is used. SI test is the number of the current image in the test subject. Length test is the total number of images in the test, and length train is the total number of images in the train data. To detect which image from the training data we need to register to the current test image, this equation is used. SI test is the number of the current image in the test subject. Length test is the total number of images in the test subject, and length train is the total number of images in the train data. 3 levels of image registrations have been done. The 2 initial registration levels are rigid and the last one is non-rigid. First, Euler and affine transformations are used to match the images globally and initially, of course. Then I used BSP line to do the local registration. For BSP line transformation, 3 levels of mesh grids are used. Mesh grid 5, 3, and 1, of course, which is the image itself. Each mesh size creates a spline order to approximate the pixel displacement. The metric for global transformations is correlation, and for the non-rigid registration, mean square is used. Here is the sample of the automatic created mask using the algorithm comparing to the manual mask. The selected optimizer for the first 2 transformations is gradient descent, and Amoeba is the optimizer of BSP line registration. Then I calculated the centroids of the areas and made an average over them to obtain the main centroid of each image. The tools that I used for this project are SimpleITica, C#, and MATLAB. SimpleITica library is used for image registration, and C# was the programming language for that. I also used MATLAB to evaluate the result. About the data, the used data is the head CT data available on MICCAI Hackathon website for task 2. I used 2 series of images which were available in TIFF format. I used ground 1 as the test data and ground 2 as the training data. About the result, the evaluation is done in 2 ways. The first evaluation is detecting true positive, true negative, false positive, and false negative image masks. For example, if the manual mask doesn't contain the cochlea and the algorithm didn't detect any area for that, it is a true positive image. As we can see here, from the 300 images, 143 images are true positive, 3 images are false positive, 152 images are true negative, and 4 images are false negative. In the true positive images, I use the distances between the manual centroids and the detected centroids by the algorithm. It could be considered as the error. As we can observe here, the average distance is about 18 pixels, the maximum distance goes over 40 pixels and the minimum error is almost 3 pixels. And in the image we can see an example of the detected centroid by the algorithm and the manual one. The red point is the automatic centroid that the algorithm could recognize, and the blue point is manual centroid. Thank you very much for your time and your consideration. If you have any questions, please don't hesitate to ask.